About some support we do for the European Soil Mission. I'm not sure everybody is aware that there is an EU initiative at high level called a Soil Deal for Europe, which aims at reversing a negative trend in terms of how we manage soils broadly in Europe. They are becoming degraded. Perhaps enhanced by lack of understanding or education. It concerns a huge part of the European soils, both in agriculture, natural, forestry, etc. And it takes a starting point that we have to recognize how many different ecosystem services that the soils help us to achieve, help nature to achieve, besides producing obviously food and fiber. There's also climate mitigation and water infiltration, etc. And those are of very high importance and even value, and we need to protect that. So there are 8 objectives in this soil mission, which is about reducing desertification, conserving and increasing soil organic carbon stocks, which is obviously a lot to do with climate change, but also stop soil sealing, prevent erosion, etc. So where is this soil mission? For the moment, it has already initiated a large number of very important research and innovation projects. But the intention is actually that it should live among the soil users and other stakeholders. So it is supposed to support 100 so-called living labs and lighthouses across all the land use types I mentioned across all of Europe, to engage stakeholders in reversing this trend and developing innovations in terms of better land use and soil use. So those living labs should be collaborative initiatives to co-create knowledge. It should be user-centered, so it should be the land users, land managers as key participants. It should be place-based, so it should be out there in the landscape. So moving research from research stations into the actual land, and it should be transdisciplinary. Now, in PrepSoil, we've been tasked to try to develop this framework and help finding the focus. So we are a lot about stakeholder engagement. And just out of this busy slide, I'll just highlight a few of the main activities. So we've been tasked to try to develop a concept and identify what you can call soil needs across different land use types in Europe. What does it take to protect the soils, to find healthy soil management techniques? We've been tasked to further develop this idea of living labs. What could be a business model for such living labs? And we will also develop web portals to engage as many stakeholders, also besides land users themselves, in supporting the soil mission. So we have a multi-actor approach, you can say. So let me first give you a quick and dirty run through of what we mean with the soil needs assessment. These are very fresh results that you can learn more about later in this autumn. But the requirements from existing and emergent perspectives, socioeconomic, bio and geophysical perspectives that determine soil health. So we want to find out what is the status and the challenges in current land use in different regions of Europe, and what are then the stakeholders' idea of what it needs to change. And we use the well-known DeepSeer framework, which is often used also by the environmental agency: driving force, pressure, state impact, and responses. So we are looking for regions where there are already, and luckily there are already a lot of initiatives among stakeholders, farmers, advisors, businesses, to try to reverse and try to develop sustainable land management practices. So we'll use this framework where we try to identify such positive and negative drivers for the land management, and what are the pressure then on the land, what is the resulting state of the soil ecosystem, what's the impact on these ecosystem services that I mentioned, and then what is then the response in terms of farmers, land managers, actions in terms of policy, etc. So we do this as a combination of desk studies where scientists review the current knowledge for that region, but then it's very much about workshops and focus groups and interviews with the land users, and you'll see the results there. So we've done that in 20 regions across Europe, across the different land use types, etc., with a large number of participants in PrepSoil. So I'll give you just one example in 4 slides of one of the regions, just to make you get the feeling. So if we talk about the drivers, and this is a combination of the researchers' desk study and the workshops with the land users, in this case mostly farmers. So we recognize in the eastern part of Denmark, on loamy clay soils, there's been for almost a century a mechanization and intensification of the land use with high use of inputs in terms of chemical fertilizer and pesticides, and heavy investment in machinery, sometimes very heavy machinery also. There's been a consolidation of farms. The average size here is not really, that's a statistical number, but you wouldn't be a farmer if you cultivated less than a commercial farmer would cultivate at least 500 hectares under his or her responsibility. Very individually owned, but there's a lot of lease of land. High average age of farmers and a difficulty of transitioning to the next generation, which is widespread all over Europe, and of course a strong focus on economic return because of a price pressure that every farmer finds themselves in. Then in Denmark, we've also for many years, more than 40 years, have a strong focus on the nutrient pollution coming from this type of farming. And there's in Denmark not far from any spot to the sea. So we have a strong challenge with nutrient pollution of our sea waters around Denmark. So we have strict nutrient regulations and compulsory use of cover crops and quotas for nitrogen fertilization, etc. Then on top of that, we have another driver, which is the climate change with milder winters, longer growing seasons, which superficially looked at is to the benefit of the farming sector, but there will also be periods of drought, more pests and diseases, and a higher pressure on the carbon content in the soils. We also have some positive drivers in terms of organic farming developed over 30 years now, regenerative agriculture practices, conservation agriculture, etc. Now these drivers leads to pressures in the form of, as I said, mechanization with a lot of tillage. There are also positive pressures now from conservation tillage. I mentioned already the mineral fertilizers and the carbon poor fertilizers, very monocropping focused rotations or annual cropping rotations with few crops, meant mostly for feeding pigs. Now also increasingly catch crops and straw adding to the soil, etc. Now this leads to a state of soils here where you will see increasing soil organic carbon loss, which obviously is the reverse of what we want to do from a climate perspective, where we want to increase carbon in the soil as carbon sequestration. That leads to reduced structural stability, increased soil compaction, also from the heavy machines that are used. So a higher bulk density leads to reduced water holding capacity, which we also see. And in times with more torrential rains and heavy rainfall events, that's not really good. So that can also lead to increased erosion and runoff of nutrients. And it can also then, that erosion leads to further nutrient loss, depletion, and then again soil organic carbon loss. So there is a negative trend on these in the States, and that leads to impacts. And discussing with farmers, they're very well aware about the impacts on crop yields, the provision of surface and groundwater, the groundwater quality, the environmental impacts, as I mentioned, on nutrient eutrophication of waters, etc. It also have a long-term impact on the farmers' economic state. So the responses is actually sometimes the reverse of what you would want, namely that you intensify your crop production as a farmer to have more, to earn more money on the short term. But there's also positive responses, as I said, in terms of introducing new technologies, conservation agriculture, etc. And there is an increased policy focus. So we need to strengthen these positive responses, and that's the whole idea of the soil mission and the living labs. So obviously, from what came out here, you can see that the farmers cannot change this, reverse this development by themselves. That we need a food system, so at least a value chain approach to do that, and therefore we need to include other participants in those living labs to develop the innovations. It's not only about developing a new method to cultivate your soil. You need markets for other crops. You need the input providers and others to assist in this. And we also need the citizens to be engaged and aware of this. So therefore, the living lab approach is about, as I said, working in real life settings in joint collaboration between all these stakeholders, but notably the land users, the advisors, the input providers, the market actors, and the scientists. And the Commission is currently, or the Horizon Europe is currently supporting this, or will start supporting this. There's just been the first round of applications for support to living labs, which are still under evaluation, and there will be more calls. So the Nations project that I'm mentioning here is about supporting, spreading this news about the potential for obtaining support for living labs and developing more knowledge on how to use that. In PrepSoil, we are supporting the multi-actor approach by trying to engage stakeholders more broadly in understanding the need for reversing the management of soils, the need for healthy soil management. We do that with trying to reach out to existing communities of practice. As I said, there are groups of stakeholders already doing this for decades. They need more support and recognition, and fora to discuss and spread their knowledge. We also try to find teaching programs and spread that. And we are building a network of soil advocates. And we have on our website tools for that. We have a web forum for these communities of practice and everybody else who wants to engage in dialogue. We have PrepSoil TV with the increasing number of good stories, I would say, about how to properly manage the soils. And we will develop a multilingual knowledge hub where people can submit any kind of documents, films, etc., in all formats about healthy soil management. So, coming to an end, the soil needs assessments have been carried out in the 20 regions I mentioned. They will be presented in different forms, including synthesis at the European Mission Soil Week in Madrid in November. So try to link up with that. If you're not able to go there physically, there will be transmissions of some of the presentations. Look at PrepSoil if you want to become engaged in this, and if you want to learn more about the living labs and these opportunities, go to the Nations website. Thank you.
WATERAGRI is the name of the project. These are the questions we were asked to cover by the organizer about the problems we are dealing with, the solutions, cases, and how we interact with some stakeholders. So problems we are addressing in WATERAGRI: water retention and nutrient recycling in soils and streams for improved agricultural production. So it's a focus on nutrients and water, and obviously in doing that we have to deal with the soil, so it's appropriate for the topic of today. I have also a map showing where we have our case studies, more or less from north to south in Europe. And with the interesting terminology, we also included Hungary as being part of the Pannonian zone, which was a new term to me before I entered this project. So the whole idea is with WATERAGRI is to find solutions at the farm scale on how to improve management of water and nutrients in agriculture. We have a sister project which is called Obtain, and they are doing the same thing, but they're working on a larger scale, on the catchment scale. We are working basically or mainly on the farm scale. WATERAGRI is a research and innovation project, and we have a catalog of solutions which we are developing and testing. And we have divided them into groups. So here are the solutions mainly focused on water. I'm not going to go through them. So they are here. And then we have solutions which are focused on nutrients. And then we have solutions which are focused on somehow both water and nutrients. So today I will be talking about two of those solutions, and I chose those two solutions since they somehow represent extremes in a way with our solution, in the sense that serious gaming, which I will talk about first, is very, how can you say, generic in a sense, and it's a very soft solution in that it speaks to a lot of stakeholders, and it's like an awareness raising solution. While the other solutions I will be talking about today, integrated physically based terrestrial system models, is a very technical solution and very advanced, if you like, from a scientific point of view. So first example, the solution serious game, it is called AgriLemma, and it was developed by TU Delft in Holland. It's a serious game about farming in Europe in the 21st century. The aim of this game is to engage stakeholders and increase awareness of these problems related to water and nutrients in agriculture. And the second main aim is to make it, how can you say, as it's formulated here, enable players to learn more about the WATERAGRI technologies and solutions. So that's the idea with this game. This is what it actually looked like. So it is a physical board game. You actually sit around a table and play this game. I played it myself. And I will not explain in any details, but it's sort of focused around the annual sequence of events for a farmer. So starting early in the season, going through the growing season and harvest season. And as you play the game, you're making various decisions about what kind of equipment you're investing in, what kind of fertilizers you're going to use, what kind of crop you're going to grow, and so forth. And then there are also some unexpected events coming in to disturb your farming life, like weather. Here it's shown on the right hand upper right. It says weather cards, so you can what might happen is that according to this game, there is a drought, or maybe there is an intensive rains, there is a heat wave, or things like that, which happen at random in a sense. And then you have other types of events which also make your life as a farmer in this game a bit difficult. The object of the game itself is to sort of gain points as you go through these years with your farm, and you gain points along 3 axes or 3 dimensions, if you like. So it's the 3 pillars of sustainability, environmental, economical, and social pillars, those three dimensions of sustainability. And I think for many of us who played the game, who are not farmers, I think maybe one of the main discoveries was how difficult it is to be a farmer and all the decisions you have to make, and the problems with making your farm profitable. So this game, as I said, was developed during the project by TU Delft. It's been tested all along the project at all our meetings. It's also been tested in various PhD summer schools and with various groups of stakeholders. So it's very well tested, I would say. And as it says here, based on preliminary evaluation of the game, AgriLemma is an efficient means of increasing awareness and knowledge. So it is quite a nice tool, and it's quite entertaining as well. So this is what it looks like when you play. Personally, my view is that this game is perfect for students. So, and I think it's also an extremely important stakeholder group, the students who will take over agriculture, if you like, or the whole agro-business. So, and also other types of students would benefit from playing this game, I would say. Okay, so I'll move over to what I call solution 2. It's called data assimilation system for physically based models. Here we have something completely different from the AgriLemma series game. This solution was developed by Forschungszentrum Jülich in Germany. It is developed to provide estimates of hydrologic conditions in agricultural watersheds. So when I say hydrologic conditions here, it's mainly about soil water content and groundwater levels. And then these in turn are supposed to be then the basis for making various decisions in agriculture by the farmer. These models are not developed from scratch. The models themselves are based on 2 widely spread big software platforms, HydroGeosphere or terrestrial system modeling platform. The living labs in this case, actually, these models have been set up at various of our case studies. This is just one of them, the one in Germany, which we call Seelhausen in the western part of Germany. And this somewhat complicated figure is trying to explain what this is all about. So if you see the text on the right-hand side, you say this is called data assimilation system for physically based models. So the whole idea is that we have these hydrological models which are already existing, by which you can simulate water and moisture conditions in the source, and it's done then numerically by computer software. And in the figure on the upper right, you see how typically these models operate, where you have the vertical dimension, and it is divided into a number of layers. For these models, you also have a similar division in the horizontal. So if you look at the map from the top, you have a grid, and then this means that you have a number of small volumes for which you make your calculations based on the physical equations which govern the movement of water in the soil. So that is how these models operate. The new thing about our solution is what is stated on the right-hand side. So the models, with the addition of PDAF, the data assimilation stuff allows correcting the model simulation with measurements to update initial conditions and parameters. What this means is that when you do the calculations with your model, and what is always the case is that you make short steps in time and then you update the status in the model of soil moisture and groundwater level. What we now do with this addition of the data assimilation system is that you can make use of sensors or measured data from remote sensing. You can bring in that information into the model, update the model, and then your forecast for the coming day or days will be better because of this update. And this is one of the typical illustrations one would use, is to just show how the introduction of this data assimilation system on top of the basic models will improve your short-term forecast. So here are then the key results, and maybe the bottom one is more important. Data assimilation significantly reduces the mean square error. It means that when you make the forecast near real time for the next day or maybe next week, the error you make in the model will be less because of this data assimilation system. And so what can you do with this? One thing that we're doing in WATERAGRI with these models is to simulate situations where you have some kind of choices to make in your management of your farm and your agriculture. Now, these models and these systems are pretty technically advanced, so it is not realistic that the individual farmer will use these models, but the idea is that they can be used, for instance, by other scientists for testing various, how can you say, interventions in the agriculture. They can also, in a practical situation, be used by what we call advisory services. So we imagine regional advisory services which have some higher sort of academic capabilities that can assist farmers maybe in a local region to make prognosis as the basis for making decisions. So that could be a more, how can you say, hands-on practical use of these models. It's also a way of general understanding our understanding of the whole system here. We were asked to say something about how stakeholders can apply lessons learned from a project. I already did that, I would say. So this is for the serious game. This is for the data assimilation system, and I already spoke about that. These are the partners in WATERAGRI. We have 23 partners in 12 countries. Lund University is coordinating, and if you want to know more, we have our website. We're also pretty active in social media, and I think that's the last one. So thank you.
Thank you very much, Atina. Thank you for inviting us here, EJP SOIL, which I'm representing as co-coordinator. And the coordinator is Claire Chenu from Paris, from INRAE Institute. So we do it together. EJP SOIL is a co-fund action that is designed to support coordinated research and innovation program for EU and the countries, and it is about sustainable climate smart agricultural management. We are with 24 countries, 26 partners, more about one partner one institute per country. We're with more than 4,000 scientists working on this program. And as it's a unique funding instrument of the European Commission, which is a combination of the funding between the European Commission and the countries, the national funding from, for example, institutes and the ministries. And another unique thing is that it has annual programming. The program runs for 5 years, and every year we can adjust the program according to the needs and the developments. And we have a wide range of activities, so it's not only research, but it's also networking, education, demonstration, and other activities. Well, there are different elements in the knowledge framework of EJP soil. As you see, they are grouped in different colors. First of all, there is a lot of knowledge development on soil health, and also with an emphasis on soil carbon sequestration. So we develop new knowledge, but we also strengthen scientific capacities in cooperation. And it's a long-term alignment of soil-related research in Europe. So we are creating a long-term community of soil scientists around Europe, across Europe, to be able to continue to work together also after EJP soil ends. Another element is supporting the harmonized European soil information, so helping Europe to harmonize soil information. I will show you some examples later on. And it's also about the transfer of the knowledge that we create, not only to the policymakers, but also to the farming sector. And because they are the stewards of land and soil resources, and they need to adapt to climate change and to mitigate it. So an important element in EJP soil is that we have set up national hubs for each of the countries that we represent. And it's a way to work in EJP soil so that the national hub members are the core, the subset of the key stakeholders that we have inventorized in the beginning of EJP soil. So from all the stakeholders in each country, we have selected a number of them. And this group of people come together 1 or 2 or 3 times a year. And we discuss with them the results of EJP soil. They provide their feedback, but they are also our ambassadors to these different sectors. So this is a very interesting, new instrument for the consultations with the national stakeholders. We also use the national hubs and also the broader group of stakeholders to make an inventory of the knowledge needs within EJP soil, also on the barriers and opportunities in soil management and the challenges and aspirations. We also did the literature review of possible needs and gaps in soil research, did some stock takes, and altogether it provided us with a roadmap with the research priorities on climate smart soil agriculture. And we use these research priorities. First of all, they were used by the soil mission to identify topics for the new calls. And secondly, we use this roadmap to make calls to get and fund within our program 44 research projects. So they are all, you see here, it's the whole landscape of projects. The ones that are with colors are projects that are funded by EJP soil itself within our consortium. And the gray ones are the projects that are funded by other funders that joined our call. So these are also another projects for another 22 million euros from 36 countries, funded by more than 25 research funders. So you see they are grouped together in different topics like sustainable soil management, climate change mitigation, adaptation, but also harmonization of the soil information and the fostering of the adoption. And this landscape also helps us to integrate really the results of these projects. We're now in the 4th year of the program, so now we have already started receiving a lot of in-between results from these projects. So I think it's a good added value of EJP Soil of actually producing this integration within the program. So I would like to, and of course at the end, after the results have been integrated, we will repeat the exercise with the roadmap and see what knowledge gaps are identified at the end of EJP Soil, so that we provide a 10-year roadmap for strategic research on soils, on agricultural soils for the future. I would like to give you 3 examples of EJP Soil results that that might be useful for the policy makers. And I'm very glad that that Niels already mentioned the problems of compaction, because compaction is one of the problems in soil health in agricultural soils, and especially with changing climate and the precipitation and the intensity of precipitation, it becomes more and more a problem. So one of the projects working within EJP Soil has been doing a literature study and combining the results from 14 field experiments in different European countries to have a look at the what is the recovery possibility, what are how soils are susceptible to soil compaction, what are the possibilities for the recovery are. And so we've seen that actually in the graph below, you see that the recovery techniques are not very effective, especially on a long term. So it's better to prevent a compaction than to mitigate it. But if you want to mitigate it, then the best techniques work in the soils with high clay content. And biosubsoiling is probably one of the more effective techniques in the regions with the regular precipitations. So if you would like to learn more about the details and the different regions, how you can apply recovery techniques there, please go to the report that is cited here. Another example is on the data harmonization of soils. So we know that 60 to 70% of soils in Europe are not healthy. It's an estimation, but in order to get a better picture of how healthy our soils are and what we can do about it, is to assess its current status and to monitor it. So for that, you need indicators to see how you want to monitor soil health. So what we did in EJP Soil is we have made an inventory of different indicators that are being used in different countries in Europe. So you see here 68 indicators that characterize soil quality. So what we did after that is we made a short list of indicators that could be interesting for the policy, for the European policy, for preparing a better harmonized European monitoring. So we selected the indicators that are relevant for policy, that are used in a lot of countries and also in the literature. So these results have been taken over by the European Commission, who prepared a proposal for the European Soil Monitoring Directive that came out in July this year and is now under discussion in the European Parliament and will later be hopefully adopted by different European countries so that we'll have a better way to altogether assess how healthy our soils are and what to do about it. And there are, of course, other aspects, not only indicators on how to measure soil health. It's also about sampling design and then analytical methods. So, and they are all different in different countries. So in EJP Soil, we are working also on the harmonization of the sampling designs and the analytical methods, and providing technical solutions for European soil monitoring. So we have a number of actions that we do towards soil monitoring directive, and I'm not going to name all of them, but I would like, if you're interested to know the background and the scientific underpinning under the soil monitoring directive, you can have a look at a number of our workshops recorded and the webinars. And the last example for the policy makers is carbon farming. One of the ways to mitigate climate change is to store carbon in our soils. And in the last decades, a lot has been doing in different countries on so-called carbon farming to store carbon in our soils. We have seen through one of the EJP Soil projects that the ways and the schemes for carbon farming may differ a lot. We did an inventory in the literature on how different countries, what type of certifications they have, and we found that there are 160 at this moment, 162 schemes for carbon farming, and they are all very different from each other. So, well, there is a lot different possibilities for carbon farming. There are also disadvantages and trade-offs. So we have tried to summarize all this information, to synthesize it. And I would recommend you to look at our Introduction to Soil Carbon Credits webinar, which is made especially for people who are new to it. We've been also advising to the proposal from the European Commission for the carbon removal certification. And we are going to have a policy forum on sequestering carbon in soils and the associated trade-offs on the 11th of October. And you're welcome to join it. But we're also not only active for policymakers, we are also looking at how we can help soil advisors, the farmer sector. What we did is an online survey on the needs, knowledge needs of soil advisors. We also did a workshop with a number of advisors, and also a workshop with EJP soil researchers to see how we can combine the needs from the soil advisors and what we already have in EJP soil. So what we see from the online survey is that there are a number of topics that were identified as, well, where knowledge is needed, and it differs, of course, per country. And we also looked at so what is the current knowledge they have and what they still need. And you see, for example, for water storage and water use, that there is some knowledge already existing, but more is needed. And we have also tried to make an inventory. What is exactly what kind of knowledge objects they would need. For example, in water, you see here the connection of biodiversity to soil structure and water. So all the soil and water connections. So within this part of EJP soil, we will be also trying to identify the knowledge objects that soil advisors need, and make sure that they become available for them through through European Farm Book, but also at different at the country level. Well, one of the things I wanted to briefly mention is the capacity building. It's very important to educate our soil experts and researchers. The coming capacity building activities that we have are the 2 PhD schools in spring of 2024, and we'll also have a training on soil sensing for researchers, but not only for researchers, others are welcome as well. There will be a basics course in this autumn, and then a year later an advanced, a more advanced course. So not only EJP SOIL members are invited, but everyone is invited, so you can find information on our webpage. So that's all very briefly about EJP SOIL, because it's so huge. But if you would like to know more, you can always go to our website, on our knowledge platform, and find out more. Thank you very much.